Can you hear me?
Yes,
Yes.
good afternoon.
Good afternoon. Okay, I think
Good
we can
afternoon.
start. I don't know if if anyone is coming, other of your colleagues, or we can start.
If you want, I can send a message in the common group, but I have no idea.
Okay. No, it's fine. It's fine. I don't know how many of you usually attend this lesson. Maybe someone is missing that usually attends. I don't know. Okay.
I would say 3 or 4, but I'm not,
Okay.
I don't know
It's
for
fine.
sure actually.
Don't worry. Okay. So today, as the professor told you, I think we are going to see together the software, CIMAPro software, that we usually use. So my name is Lorena. I'm a research fellow at the University of Tuscia, and I'm working with the application of life cycle assessment in the livestock sector within my fellowship. And I'm going to share my screen so that you can see. So let me know if you can see it here.
I see.
Okay. I think you are seeing the whole screen. Yes. Okay. Perfect. Okay. So first of all, the main the main window of this program is of this software is this. As you can see on the left side, you can see some of menus and some of categories of these menus, and you should recognize some of them as cited in the theory part of this course. So goal and scope, sorry, inventory, impact assessment, and interpretation, which are the four main phases in an LCA assessment. So this division has been taken again in the software. So this part we are currently in the wizards, but we can easily ignore this part. So the description here is very qualitative, let's say, part. It's up to the practitioner to fill this part. As you can see here, you can fill part text parts. So the name of the assessment, some comments, declare the type of the assessment you want to perform, also the goal, the reason why you are performing this assessment, and other details. But it's not mandatory, this part. So if you don't want to, for example, to fill this part, it's not you will not have any results. So another important part of the of an assessment in particular for our type is the selection of the libraries, so the databases we want to use for our assessment. Of course, an assessment differs from another. Basically, if we think of the sector, for example, the assessment is focused on, for example, we want to assess an LCA, we want to assess the impact, the environmental impact of a bottle of water, plastic bottle of water, or the assessment of the environmental impacts of an organization, of an industrial process. So there are many different sectors. And I don't know if you, in the theory part, you have seen a list of different databases, but here we can find mainly 3 types. So the agri-footprint database is focused on the agricultural sector. So, for example, here we can see we can find very detailed processes and inventories for crop cultivation, animal production systems, and so on. Another database we have in this version of the university license is Agripali. This is a French database focused on the agricultural and food products For example, this database is used to assess the environmental impact of, for example, catering, so food production. But not only consumption, but also starting from the very initial process, so the agricultural crop and cultivation, for example. The most used one and very important one is EcoInvent. This is a very complete database, but of course, even if we can say that it's complete, at the same time, it's if we want to focus the analysis on a specific sector, it's not so complete. So we have in this database we can have processes and data coming from different sectors: energy production, transport, building materials, chemicals, plastics, and also the crop and the agricultural sector processes. But of course, each one is focused on different type of sectors. We can say that EcoInvent is the main one, and the one that you should have if you are not sure on how much sectors you will focus your studies. So 1, 2, 3, and also we have also this database that was made on the is compliant, let's say, to the ILCD, that is a sort of guide coming from the European Commission, and at the same time, this database is compliant to the environmental footprint method. This method and also this database is we can say that it's focused on the European countries' processes. As you can see in this list, within this list, we can also select one or more databases. If we want to select the I don't know, the process for the energy mix coming from EcoInvent, but we want to be more specific for another process for the European countries, we would be able to select also the environmental footprint database. So we can pick also 2 databases, for example. Here, already selected are the, let's say, the database of the assessment, impact assessment methods that we will see them soon. So this is the main choice an LCA practitioner needs to do at the very first time. Also, you can see here that EcoInvent database, for example, has different versions. I'm quite sure you know that which are the versions. So the APOS, so allocation at point of substitution type, but also cutoff by classification, and the third type, the consequential. So here you need to select also the type of the database, not only the name of the database. At the same time, for each of these versions, you see that are two different types, system and unit. In simple talking, these two types will bring you to the same results. But obviously, if we want to make the work easier, we should select the unit type. I'm saying this because I will show you when we are opening and see the processes inside. In the unit processes or in the unit type of database, the single processes are simplified. So we are not going to see all the processes, because you need to imagine that a process is like a big box that contains other boxes in the other boxes that are referring, and each box contains other boxes. So it will be a mess to see all these boxes. And to simplify the work, we select the unit type. Okay, so moving to the second phase of an LCA, the inventory part. Here you can see that we can select very different type of processes. So these are the main categories: material, energy, transport. That of course is useful if we want to look for a specific process. But at the same time, we have the find tool, let's say, to help us with the search. I'm going to show you all the different features of the software, and then we will come back to, with an example, so that we can see very specific how we can add data, insert data, and also see the final results. Okay, so here are the main categories. We can open the very general category and then go further in the research for the actual exact process we are looking for. And the second step is to create the model of our product. So the product stages is the next step. We can also add in this part that not all the processes could be the better choice for you. And in fact, here on the right, you can create your own process. Okay. You can create your own process in order to be more specific, and also in the case of no processes can be selected for your case. Then I'm going quickly, but you can be sure that we will see all the different steps soon. So here in the product stages, we will model our product. Imagine we are talking about the water bottle I said before. So at the same time, we want to assess also only the assembly phase, the assembly stage, or all the life cycle. And we are going to consider also the disposal scenario or not. Here we can split all the life cycle of this product in different stages. At the end, we need to assess our product, the impact assessment of our product or service by selecting a method. Okay, so here you can see that the methods are categorized, and we can select the method we want to use. So European ones, global ones, and also single issue. Single issues means that only a specific impact category is considered. But maybe with an example will be more simple to imagine. Okay, so I think we can start with the example. So it's a very simple example. We assume that we want to that we want to assess the impact assessment of a wooden shed. Okay, so a wooden shed that is commonly used in a house. This wooden shed is made of only wood and some steel, so for nails or other steel parts, but in a very sorry, in a very small part, let's say. I'm looking for my notes, sorry, so that I can not lose anything. I don't know if you have questions.
For now, no. For now, not questions. Not any questions.
Okay.
I also haven't questions.
Okay, perfect. Okay, just give me 1 minute. Okay, so we said a simple wooden shed to be used in a private garden or a house, made of just two materials, so wood and some steel. And there's no packaging and no maintenance, no paint, so very simple. Without windows, no doors. It's a very simple shed, okay? So, of course, we need to build the, let's say, the process in order to have this final product. The first process, of course, if we are talking about wood, it's obviously regarding the felling of the tree. So since I'm sure, because I already checked and I create this example, this process, it's not present in no one of the database we have selected. We need to create a new process. So I already created this process, but I will show you the screen to create a process from scratch, let's say. Okay, so here in the very in the initial part, you see that we have these three parts of the screen, so products, inputs, and outputs. Okay, So on this first line, so outputs to Technosphere, products and co-products, we need to declare which is the product, the output, let's say, in this way, the final product of this process. We need also to declare the amount and the unit, but it's very you can change also the for example the quantity. We are if we are not talking about mass, we can select, for example, energy, an amount, and other quantities, let's say length or transport volume. So it's very up to the practitioner. And also the unit. So if we don't want to talk about kilos, we can select other units, of course. Okay, so this very first part of the screen refers on the output of this process. But of course, this process needs some inputs, and we need to look at the second part, so the input part. These inputs are categorized. So we have inputs from nature, inputs from Technosphere that are materials or fuels, and other inputs from Technosphere such as electricity and heat. The last two, so materials, fuels, and electricity or heat, these two lines, it's a division that could be useful, but we can, for example, add an electricity process also in the second line. Okay, since are the same of the same type. We are talking about the input from Technosphere for both, so we can sum them in one line at all. Inputs from nature. We in this case we are talking about the very simple inputs. If we double click on the line, we can see in this other window all the process or all these inputs that we can select. Okay, so for example, here you can see the bauxite or aluminum or other very simple inputs taken from the nature. But on the other hand, if we double click here, you can see that this list is the same one we saw on the process category, on the process part. So it's like before we were looking into a library, but here in this moment we need to select the process better for us in that library. So here we need to select again the process we found useful for our case. Okay, so here we were talking about materials and fuels. So for example, I will open one fuels, natural gas, and here you can see different processes, all regarding natural gas, of course, because we selected the subcategory natural gas. And here you can see that every process, even if it's actually the same, so the first three are almost the same, but differs from the country, because these two letters refers to the country. So the first one was for Germany, and then Norwegian, and then Russian. Okay, so here in this other box on the bottom, you can find the description that will help you for sure for the selection of the useful process for your specific case. Okay, so the letter of at the end of the process are referring to the country, but also the ones contained to the bracelet. I don't remember. So here, CH is for China, is for Switzerland. For sorry, DE Germany, and so on. So if you want to be very specific with your analysis, of course you need to look for example, if we want to look for the Italian processes, ET. Okay. Of course, natural gas, Italian process, import from Algerian natural gas. Okay. So coming back on this screenshot. So we saw how to select the input processes. But of course, a process has not only have inputs and a final product, but also has other outputs that are reported here on the bottom. So in the third part, let's say. So here we can see different type of emissions. So emissions to air, emissions to water, to soil, and so on. Here you can see also that are available other type of outputs such as social issues or economic issues. I want to specify this, but I think you already know. An LCA assessment is very focused on the environmental sphere. But nowadays, the softwares and also the practitioners and researchers are trying to add also the social and economic aspects. I've never used these two lines, so I don't know, but they had this in order to make the assessment more complete. I'm quite sure that with this software, an LCA, social LCA, and a life cycle costing assessment could be performed, but I never did. Another important line of these part of outputs, it's the very final one. So the outputs to technosphere, because here, if we double click, we see that are many options regarding the waste treatment. So waste treatment for agricultural, for hello, hi. Okay, sorry. Excuse me for 1 minute because I need to connect also the PC. 1 second. Mhm. Here it is. Last year was one. Okay. Okay. Mhm. Okay, so we were seeing together the software we usually use for LCA assessments. I will okay, I will show you quickly what we already saw together. So this is the main window. So as you can see on the left side, there's this list of categories and options that you can select. And the main ones that if you want to use the software, you need to use are the one referring to the main phases of the life cycle assessment. So if you read closely, you can see goal and scope, which is the very first phase, the inventory, so the life cycle inventory phase, impact assessment, so here, impact assessment and interpretation. But we saw also together that many different libraries, so databases can be selected in order to perform an analysis, which is you can select the one that better fits with your goal, and also in particular we saw that these three main data sets.
Sorry, but your background 7C.
It's okay now?
Yes, okay.
Okay.
Thank you.
Okay. So in this list, you can select the one, the database better for your use case, and for, of course, each database. They're very different databases. One can be focused on an agricultural sector, one on energy sector, another on chemical products. So depending on your study, you can also select. You can obviously select the one better for you. The majority of database, of course, are you need to buy them, to pay for them. And the main database, I think you saw that in the theory part, is EcoInvent. That is the one, the more complete one. And the next phase that we were actually seeing together is the part of the processes. So it's a very this part of selecting selecting and creating also the better process for your analysis is the important one of use and the an LCA assessment. So here in this screen you can also see on the second left side another list. And this is the list of the processes that are obviously categorized in many different types of processes. So the one referring to material, energy, transport. So you can better look for the one better for you that you are looking for. And very quickly, also the impact assessment part. So the list of the methods, the impact assessment methods you can select to assess the impacts for your study. So we were talking about an example in order to better understand the how the use of this software can be done. So the example was focused on the construction of a wooden shed that needs to be used in a private garden. This wooden shed is made of only wood and some steel, so for nails and other steel parts, but only these two materials in order to simplify our example. And what did I say? And okay. So we were talking about the how to create a process, so a new process. In order to create a new process, we have this screen in front of us. This screen is divided into three main parts, as you can see. So products, inputs, and outputs. So here you need to declare the output, which is your product or more than one product coming out from this process. In the input parts, you need to declare your inputs, so the one from nature or from Technosphere. From Technosphere, we can select processes as the ones we saw in the library. So here, one of the process we want to use. So for example, we saw in the category of fuels also natural gas and the very specific one. So maybe this one or another in order to be more specific for our case. We were talking about the outputs because obviously in this process we surely don't have only the output, the product, but also we will have emissions that can be to air, to water, to soil, and here you can see the different category. An important output in a process is also the very last line that refers to waste and emission to treatment. So, for example, we will see in a couple of minutes how we can model this type of waste. I'm saying how can we model, but basically we need to select something. Okay, it's always the selection of something or the creation, because of course we cannot be sure that everything that we need is available. So this is the structure of a process. Okay. But I've already created a process for our example. And starting from the very first, let's say, phase of this wooden of the construction of the wooden shed. In order to obtain the wood, we need to do something with a tree. Okay, so in order to obtain a trunk, for example, oh, sorry. Okay. Here we can see the already created process that that refers into the felling of a tree. Okay, so the output of this process is 1 ton of trunks. Okay, but of course 1 ton of trunks is obtained from 1.25 ton of wood. Okay, for example, here I already look for the raw material, so the input from nature that better fits with our example. So wood unspecified standing 4 kilos. Okay, and I selected this. I've declared the amount, so 1.25 tons. And in order to obtain the trunk, also the processing, let's say, needed was chainsawing. Okay, so in this case, I selected the chainsawing process. That, as you can see, has a different type of unit, of course. So in particular, I think this process already existed, so I can show you. Yes. Okay, so the chainsawing process was an already existing process. It's the same, this screen is the same of the one we saw before, but the one saw before was, of course, empty. Here we can see a process, an existing process field. So, for example, for the chainsawing process, the output, okay, the output unit was declared of 0.025 hours. Okay, so the quantity is time. And at the same time, we see that inputs coming from Technosphere are 2. So petrol and light fuel oil in this amount. Okay, we don't need to question ourselves about something. We are only seeing the how this process is made. And in the very last part, we see the outputs of this process. So emissions to air, there are three emissions, 3 gases, 3 substances, okay? But of course, we are only looking at this process. We don't need to modify it. But an interesting detail that we need to mention is the let's say the unit how can I say the flow reference unit this process use. So all this process has been modeled for this amount of chainsawing, okay? But as you can see, in our example, we have a different amount, okay? So we don't have this type of hours. We have, I don't remember. We have 0.05 hours. So the software will automatically do the calculations, okay? So even if the process of chainsawing has a different flow reference unit, the one selected in our case will be the one accounted in the final calculation and the final assessment. I don't know if it's clear, this type of step we made, but basically it's the difference between flow reference and functional unit that I'm sure you saw in the theory part of the course. If you have questions, just interrupt me without problems. Okay, so we saw the very first process of our assessment.
Sorry, can I make a question about this?
Yeah, sure.
This 5%, I just what I do not understand is how it's calculated. This 5%. I mean, for 1 ton of trunks, we know that the chain sewing is 0.05, or how to get to this 0.05?
It is just an amount that you is basically the data you would collect from the, I don't know, the industrial plant of tree felling, tree sawing, let's say the manufacturing.
Okay.
So in our example, I took this data, but you
Okay.
don't need to make a calculation. It's like to fill a survey, let's say. We
Okay.
need
Okay.
to
Okay.
fill a table with the data.
Okay. Okay. So you put this. Asking to who has done it, basically. In theory, you do like this. Okay. Thank you.
Yeah. No, this example is the one reporting from a tutorial of the software that I can share to you after this lesson, so you can sing again something that's not clear, but yeah, here you can find it. I follow this example so that I can have the material to send to you if you want. So as you can see in this, I think you can see it, yes?
Yes.
Okay, I'm forgetting that I'm sharing with you the complete screen, sorry. We should be here. Here. If you read here is the example. Okay, assume you want to make an LCA. We are basically following this tutorial, okay, but in a more active way. And the data we were talking about here, felling the tree. The first process described the felling of a tree, blah, blah, blah. And
Okay, 3 minutes. There is written like here. Okay, okay, 3 minutes, so 0.05%. Yes. Okay.
Yeah, sorry. I didn't specify this. Yes. Okay,
Thank you very much.
don't worry. Okay, so let me pick the exact page. Okay, so if we want to have let's say clearer view of the process we have created, we could use this feature that is called network. So in this case, we are like calculating the impact of this single process. And as you can see, the main impacts are coming from the chain sewing. But I'm not quite sure about this. But okay, in this phase, let's focus only on the representation. Okay, so this software has this feature which can be used to have a representation of the different composition of a process. In our case, it's very simple because we only have selected one process coming from Technosphere, that is chain sewing. But on the other hand, we should also need to see the wood process. No, only this. Okay. Don't forget this feature, this representation, because at the very final phase, when we'll have the complete life cycle of the wooden shed, we will reuse this. Okay. So we created the very first process that was the felling of a tree, and we obtained this process for 1 ton of trunks. Okay, so we know now that 1 ton of trunks needs these inputs and also have this waste flow. I forgot to say this. We have also a wood waste, because as you can see for the quantities, we have in input 1.25 ton, but we have only 1 ton of trunks. So 0.25 ton of wood is missing, and this quantity is specified in the example and also for logic. It's a waste, so we declare this quantity as wood waste. So for the final waste flows category. Okay, then save. Yes. Okay, then we need to model the second process. Okay, so we need to so these trunks, these logs needs to be converted into planks in order to be used for the shed. Another step, another process. So I already created the planks process. I'm saying planks process, meaning that the process that brings us has output planks. Okay, so for example, here we are seeing usually I follow a simpler example, but I think we can move on the second difficulty here. So as you can see here in this process, we don't have only one product, but we have 2 products. Okay, so in this case, we are talking about a process which inputs, so trunks, for example here, the trunks and the electricity and the transport. For transport here, we are talking about the transport, don't remember, with the freight, Yeah, I think from the forest or from the industrial plant where we obtain the trunks to another country. In fact, we have 250 ton kilometers as unit. So talking about this process, that is a multifunctional process, okay? Because we don't have only planks, but we have also sawdust, okay? We have two products that, of course, we are only interested on planks. For a multifunctional process, I know that you know, an allocation needs to be made. Okay, so it could be an economical allocation, energy allocation. So based on three criteria: economic, mass, or energy allocation. Of course, in this case, talking about wood, mass allocation is the better one. In the example we are following, the allocation for this type is the mass allocation for this process was declared to be 60% to planks, as we can see here, and 40% to sawdust. Okay, so basically, it as I said, is only to fill the gaps. So we saw the empty window, empty screen, and I have only filled the different options. So here we have 0.8 ton of planks coming out from this process, and at the same time 200 kilograms of sawdust. Other inputs that the example needs to be needed to be added were about the nitrogen dioxide or carbon dioxide, but also in this case we only need to select. So double click on the line, look for the emission we need to add, so carbon dioxide. In this case, as you can see, there are different types of carbon dioxide, so biogenic, fossil, land transformation. These are very specific types that not always it's not common to use this very specific type of carbon dioxide, but if after a survey you send to your client or the one managing the industrial plant, if these are able to specify the type of carbon dioxide, of course, it's better to be more specific. But even if we select the very general one, so without specification, it's okay for the final calculation, okay? So here is another process, but since we are talking about a process of which has two products, these will automatically create two processes. I'm saying that here you can see that we have planks process and sawdust process, but if we open the sawdust process, will be exactly the same. Okay, so it's like doubled, but with different names. Because if I need to, for another process, not a wooden shed, if I need the sawdust as an input for my process, it's very intuitive to select all the sawdust process. Okay, so selecting sawdust process means to take into account all the process, even if the same process will bring you to have also planks. Okay, But obviously, the environmental impacts for these two processes will be different on the total amount of the main process, because we declared the allocation. Okay, so it's like we need to see this process as a 100%, but if we need planks for another process, this process accounts only for 60%. Okay, you need to have this clear. Since we are talking about allocation, and we are talking about allocation because we have a process with two products. Okay, let me know if it's not clear. So we have completed this process part, let's say. So this part, in my opinion, is like part where you need to prepare your tools or the processes that you will need for the second phase. The second phase is to assemble, let's say, these processes we have created. Okay, for in order to have our product. So we saw this different categorization of the product stages here. So the assembly, life cycle, disposal, etc. But it's not mandatory to fill all these stages. It's useful if you want to have how can I say, a division of your process, but it's not useful for your final assessment. If you already know that you need to have only the impact assessment of the whole of the life cycle of the product, you can directly fill only this part. Okay, so the life cycle part. But since we are following the example, and I think it's simple to understand following these stages, we need to assemble our wooden shed with the processes we created. So normally we will click to new, and we create the assembled product, but in our case is already created, so we need only to see. So this wooden shed, has written here, is made up of these materials or assemblies. And for the assembly of this wooden shed, maybe some processes were needed. So for example, following the list, the materials of our wooden shed are planks. So here is the process we created before. So the plank process we created before, we select this, and then we declare that our wooden shed, so the assembled product is made of 150 kilos of planks. At the same time, still, as we said before, the steel we are talking about was the one of nails and other small components. And we reported here 2 kilos. We selected steel here. So in the process list, assembly and materials list. So material, metals, I don't know if why is in Italian written, steel market, and here we selected I don't remember. low haloed here. But as you can see here, still low haloed, okay, global, but hot rolled, unalloyed, I don't know. The example was, the tutorial was very simple, but here, these are questions you need to solve. Which is the different? You need to have some research, and if the producer of the or someone doesn't give you so many informations, you need to make the decision on your own. So maybe the low allowed steel is better, and it's commonly used for this type of assembled products. So that's why the example, and also maybe you as practitioner, you can select this type of steel, okay? And you select. It can be very simple, I know, just selecting and reporting and in adding data. But the main, the time-consuming part of an LCA assessment, it's not this. It's this, we can say that is this part only for the result and interpretation, because we need to fill all these gaps, all these options in order to have our final results. But the software will make the calculation, and you only need to, the most difficult part is to collect the data in the version, in the useful version for modeling all of these, okay? So for our example, it's very simple, but it's not so simple. And another process, the process we need to also add in this part is the, I don't know if why they had this process here, but this kind of transport is the transport that the consumer make in order to go to reach the shop, and not bring it home. It's only one way. I remember this detail. So these 10 kilometers are a median-based data for this example. Also, in this case, it's a fitted number, let's say, okay, 10 kilometers. But as you can imagine, you need to ask also, okay, this transport is one way, or one way going, so reaching the store and coming back to home, but the consumer, maybe one consumer is more is closer than another. So you need to also assess these median values in order to add one simple number, okay? I don't know if you want to have a break now, or maybe other 10 minutes and then we stop. As you want.
For me, it's the same. I can even continue,
Okay.
but I don't know the others.
For me too.
Okay. So we continue 10 minutes and then we have a break. Okay. So then in this part, in this phase, now we have to break. I don't know. Guys, can you hear me?
Yes, I hear.
Okay. Yeah, we don't have the we need to have a break now because there's some problems with the electric system here, and
Okay.
we don't have the
Okay.
okay.
Okay. Good.
Okay, 10 for 15 minutes break, okay?
Okay.
Okay, so we can continue. We were talking about the assembly stage. So we model the assembled product, and we have this wooden shed. Okay, so the name that we give to the assembly stage. The next phase we could perform, obviously, all these stages, all these phases, the decision to um, um, go further on the stages, it's always on the LCA practitioner. In the life cycle, of course, we need to assess, we need to take into consideration also the other step that follows the assembly stage. Okay. So for example, here we can see that the life cycle of a shed is made of the assembled product, so the wooden shed we created before that we need to select also here, and also declare the amount. Okay, maybe when we in the very initial phases of the life cycle assessment, you in the goal and scope you need also to fix a functional unit for your study. It could be possible to have a functional unit made represented by 10 pieces of something. Okay, it's not mandatory to always consider one single piece or product. Okay, so maybe in the assuming that our functional unit is not a single shed, wooden shed, but 10. In this case, considering that we want to assess the life cycle of this product, we can you can declare 10 as an amount, even if the assembled product we modeled before was for one wooden shed. Okay, the software will automatically do the calculation, of course. But obviously you need to remember that you put different numbers that you are referring in the assembly phase for only one piece of only for one shed, and in the life cycle 10 or more. So the assembled product has been selected, and in this phase, another thing that needs to be declared is the waste or disposal scenario. In the case of the example, if you will see the file, the PDF, you will see that a very complex process of modeling was made for these scenarios. We are not going to see this complex modeling. But in order to have a scenario, also in our example, I have selected this scenario. Okay, so the incineration of municipal solid waste, even if I know it's not the perfect type of scenario for this case, but maybe maybe we can select another one. I don't remember, because for these kind of scenarios, since the since the studies, also the databases are not so full of data. And for these scenarios, you need for sure, almost for sure, you need to model your specific scenario. Otherwise, you can select the existing ones, and one between these existing ones is the incineration. Okay, as you can see, incineration is very it's almost the same. It only differs from the country where it's made. Also, landfill, municipal solid waste. See, for recycling, it's we don't have so many options. Okay, so the life cycle of our shed is made, and we could say that the modeling phase has ended. So it's completed. Of course, this process of modeling can be modified until the very last time you want to. But once you are almost sure of your decisions until this moment, now we can assess the impacts. Okay, as I said before, you can, of course, select the impact assessment method that better fits with your goal. So, for example, if your study in your study, you have declared you want to assess only the carbon footprint of this wooden shed, of course, it will be simple to select a single issue method, such as the carbon footprint method that is available by the EPCC method. Okay, so here we are talking about the global warming potential. I think you have this part in the theory when you saw the different impact categories. I think the first one was climate change, and so basically this method only do the calculation in order to have the CO2 equivalent emissions for a product. Okay, this IPCC 2021, what does it mean? This means that the characterization factors of the greenhouse gas emissions are updated as to the very last versions of the IPCC. Okay, so for example, before these, if we want to look in the superseded method, so the methods that are not recent, so it will not have sense to use them. But if you need to make a comparison using the same method, even if it's superseded, you can run the calculation also with this. You can see here that the global warming potential method has different factors. So IPCC 2001, 7, and 13. Okay, this means that different emission factors were used. For example, if we want to look at the factors, we can also do this. Let's say that we don't remember exactly which were the factors, the IPCC factors in 2007. we can see the method, and also here is the very general part with the description, but I don't think they're reported here. Here in the characterization, you remember that there is this characterization phase in the methods, and this means that to each substance has different let's say factors, but I understand better this thing calling it weight, even it's not correct, because as you know, we following the characterization phase or step, if we want to mention it as a step, we could have also the weighting. So if we want to see these as factors or weights, at the base we have two, let's say, substances with two different values. Okay. So for example, carbon dioxide is one, and it will be one for each of these version types. But the one differing are, of course, methane, 25, and the other is dinitrogen monoxide, 298. Okay, so we have 125 and 298 for this IPCC method 207. Of course, for the current factors, these current factors that we have in 2021 are not the same. But I'm showing you this because if you if someone is not sure and wants to be aware about which are the factors that are used in a method, you can also look at these things. We said the nitrogen monoxide here is different, so 273, and the other was methane that methane 29.8. Okay, so it's just a tip. Okay, if you I usually want to check. This check could be also useful. I'm saying you this because in a study that I made recently, I needed to make a comparison between studies, literature studies, that for the same product, that in my case was dairy cattle milk, that for the same product use different methods. Okay, so one study, because he wants the study wanted to be focused only on the carbon footprint, of course, used the IPCC method 207. Another study, okay, the same carbon footprint, but IPCC 13, sorry. Another, again, use the CML. The CML method is here, is a European method that has the receipt. I don't know if you you heard that. It's not focused only on one impact category, but these have I think 13, 15, around 10 impact categories, but I needed to be aware about which were the factors that were used. Okay, even if the work, the study to do for the other two studies using the IPCC method, even if they are referring to different times, it was simple for those two, but for CML, I needed to open the software and look at the things we saw together now. So I opened the CMLE baseline view, characterization. Okay, let's see in the global warming 100 here, how much was the factor of methane. Okay. And it was like a double work, okay, but it has ends. If you need, all the factors are reported, just to say that. So we were talking about single issue methods. So, for example, for carbon footprint, this one that we saw together. For energy aspects, it can be used also the CED, meaning cumulative energy demand, and others like also the use stocks. This is the method for the toxicity. But usually when we are talking about an LCA study, the LCA means to assess all and whole life cycle of a product, and at the same time, it means that all the main impact assessment impact categories are assessed. So for sure, if you are looking in the literature, if you're looking for LCA studies, you will for sure find studies with recipe method or CML or others. CML or of course the APD for the certification. Okay. But RECIP and CML are the ones taking into consideration many different categories. So, for example, in our case, we want to assess this life cycle of the wooden shed with the RECIP method. We will select the midpoint version, because if you remember, the midpoint and endpoint version of a method are very different. So we are currently choosing to stop into the midpoint, because we want to have, let's say, more concrete results, let's say, for these, I don't remember how many are. Let's open and find the exact number of 3, 6. Okay, more than 15 impact categories. But of course, we will see that it's not sure that all these impact categories are important for our case. Okay, and how can we say that? Doing the calculation, so running the analysis. So coming, I think I said the majority of things. Okay, yeah. Also, in addition to the carbon footprint, many studies, but it depends, of course, on the sector that we are operating in. Many sectors can use also the water footprint, but it's a very complicated thing. And luckily, I didn't have the chance to apply this kind of assessment at the moment. So coming back to our life cycle. In the buttons on the top, we can select the analyze tool. So here we need to specify the method we want to run the calculation with. Okay, in this case, we already mentioned receipt, but midpoint. midpoint. Okay. For one piece, one life cycle of a shed. Okay. And we mentioned in the life cycle of a shed one piece of assembled shed. I'm quite sure. Okay. But in our case, it doesn't. We don't care so much about this. Okay. So it's running the calculation. Okay, so we have some results here, but it's not so. Another thing, another aspect you need to have clear when using this software. This software will never say to you, no, it's wrong. Will never give you error in never. So you have to be aware of this, and you also need to be aware of what you what did you put as data. Okay. So here we have only two different let's say phases or processes. So in the light green, we have the disposal scenario, so the incineration. And in the dark green, we have the assembled shed. Okay. But this representation doesn't give us so many information about the impact category. About the impacts, sorry. For example, what are the impacts of the wood of the, I don't know, the trunks process in order to obtain the plank. So going back into the phases of the process, we are not seeing anything of this. But before doing this step back, let's have a look on what we have in front of us. So this is a graph that will be that comes out automatically. But you can adjust the results. So if you don't want the graph, you can click here and have the numbers. Okay, that will be different because each impact category have different units. So as you can see, the global warming has this CO2 equivalent, and others, for example, the eutrophication has the kilograms of phosphorus equivalent. The normalization also step can be made, but the normalization step, if you remember, is the step where all the different impact categories are reported into with a unique value. Okay, and at the same time, this step is not so commonly used. But if you want to do this step, also we have also this feature. As I said before, when we saw this graphical representation, not as a bar chart, but as a tree, a network. The same network will be calculated when you run the analysis with a method, and also in this case, we can have it. Okay. Okay, so if we look better here, we can have a useful representation that in my case I always use this when I have to report the network also of the product that I modeled. The only thing I don't remember how to zoom out. Zoom mode, okay. Then okay. Okay, sorry. So in yellow we have the life cycle of a shed. The life cycle of a shed, as we modeled, is made by the wooden shed, the assembled shed that is in blue, purple, blue, and the disposal scenario, so the municipal solid waste. And if we have a look below, we can have also, we can see also the other processes that we selected in, for example, in the planks process, we had the electricity. We had the electricity, yes, the electricity coming from the chain sewing, but we can try to have it present. With this percentage, we are only saying that I want to see only the processes that have a weight that a major weight of this percentage, okay? Not below. Okay, so for example, this process is still low alloyed, is 1.9, and we can see it, okay? So, okay, here. So the wooden shed, as we modeled, is made of planks, steel, and the transport for the made by the user in order to reach the shop. We say that. And this, okay, it's very simple because our example was simple, but it could be useful to have this type of representation when you need to see how the processes are involved together. And there are some cases where one process can be cited or can be inserted in two different processes, like the material processes. We are seeing this kind of representation in the normalization assessment and for global warming. But if we want to change the assessment of this network, we can do it. For example, since it's the simplest one, I will select characterization and global warming. And you will see how this representation may be different. I'm not so sure. In our case, there are not so many processes, so it could be also the same one. Basically the same. But of course, I think the percentages are different. So here, the percentages here are referring to the let's say the load of the process into the step, the following step or the following stage. Okay, so the 100% of life cycle is made by 48% of wood and shed and 52% of the solid waste. Also, the thickness of the line represent the load. As you can see here, planks, the line is thicker than the other two, And but let's try to select another impact category. Maybe it's different. Freshwater eutrophication. Mhm. Sort of different. I will zoom in. Okay. So basically, this part is the same because, of course, the life cycle of the shed is made of the assembly product and the disposal scenario, but here we have these two processes that I'm not sure they were present before. Maybe yes, I'm not sure. But in this case, we can say that this 46% of this disposal of the incineration scenario is made by 45% of the municipal solid waste in Netherlands, and other 2 kilos from scrap steel, because we have steel in the shed. The same time, we can have some consideration about something more. No, in this case, for example, we can see that the transport passenger car is always the same. And in this specific case, transport passenger car with internal combustion engine, blah, blah, blah. This process is composed by these other two processes, okay? And for example, we didn't know that, but maybe in our case it's not so correct, and by only seeing these, we can have a step back and change the transport passenger process, for example. Okay, it's a very iterative process, this kind of assessment, but because you need to be sure at the end of all your considerations, all of your assumption and choices, and you need to report all of them, because by reporting them, your results will have more or less value. Okay, of course. So other type of results that you can obtain from this software. So the network we saw now, the impact assessment that you can export this table. So the values, or the graph. Also the graph, you can export it. You will have also the inventory. By saying inventory, we are saying that we will have the list of the substances that are counted into the processes you have selected. Of course, it's not so useful to have this huge list, but maybe you need to have some considerations about a specific substance or a group of substances, and it could be also useful to have the list and look maybe better for the compartment or the total amount or where this substance is present. Okay, maybe here you can see that, for example, the substance X is present only in the wooden shed assembled product. Then another feature is the process contribution. By saying this, we are talking about the contribution of the single processes. You have to remember that we selected some processes already existing, but we have created the majority of them. For example, when we created the process for the trunks, we selected the sawmill, and that process was an existing process. And as I said at the beginning of this lesson, each process in the software is like a box. So it's not so it's very logical to have all the list of all these processes. Okay, because maybe let's have a look in the process of the trunks. We select this chain sewing, and if we open this process that we have already opened, we saw that between these two inputs we have petrol. If we open the petrol, okay, if we open the petrol process, we will see, even if it's on another database and it takes time, we see all the other processes contained. Okay, these are all the things mentioned in this process, and by only by selecting this process of petrol, we are selecting all of these. Okay, it's like selecting a package that contains other packages and other packages. Okay, there are so much things to consider. That's why also the calculation takes some time to have the final result. So thinking, okay, I need only to add a thing, and then I want to run the analysis on the assembled shed, so the previous stage, because in this way we can see the impact of the different materials and processes contained only in the assembly stage. Okay, so here in this case we have three colors. So we have the planks, material, the steel, and the transport. Okay. In this situation, more consideration can be made. For example, so maybe the climate change is an important thing. I don't remember which was the one. Single score? No. Normalization. Mm. No. I don't remember the method I've selected for this calculation. Word receive endpoint, and that's why. Midpoint. For your final exam, it will be only an oral test or also a practical part? No? Just oral? Okay. Okay. So now impact assessment. Okay. Here. So, these are the results we saw before, and they're good, but we cannot say by only seeing this bar chart which are the impact categories more not important, but important to consider for this product. This consideration, so this selection, could be made if we do the normalization step. And in our case, the software will make it automatically. So if we are doing an assessment for this wooden shed, and we would want to reduce the number of impact categories to consider, we can choose the impact categories that have more points in this case by the normalization phase. So, for example, the global warming, in our case, global warming, ozone formation, and human toxicity, human health, and then also ozone formation and fossil resource scarcity. Of course, it will not be so simple, of course, but hand help could be taken from these. So we could select these four and then comment and then ask to ourselves, okay, but why only these four categories are the most pertinent ones to my product? Okay, I could make a literature review and see if other studies has similar results for these four main impact categories. Okay, so it's not only to run the calculation, have the graph, copy the graph and report it, but also comment and compare by saying compare, also the comparison could be made. Comparison in which way? Let's think about the very simple example when someone can talk about life cycle assessment. So we want to compare the assessment of the plastic bottle of water and the I don't know, the Tetra Pak container for water. Okay, we want to compare these two products. Obviously, all the let's say issues to fix functional unit to do this comparison. We are not talking about this, but we are talking about the comparison of the impacts that can be made. So for example, we can create, we could create another wooden shed, maybe like this copy. Wooden shed, we can call it Eco. That's the ecological version of the other, and I'm just doing an example, okay? So instead of 150 kilograms of planks, it has only 10 kilos, something different to the other, okay? It's not so different, and these changes are not ecological changes, but just to show you, maybe also these. I want to change something so that we can have different results. That we can select these two. Oh, sorry. These two. No, I'm gonna put something. So these two products, okay, assembled products, and compare them. Okay, so we can run also a comparison between one ecological shed and one traditional shed with the midpoint. Okay. Okay, so here you see the same results of before, but making the comparison. So of course the traditional shed is the traditional. The light green bars are have more impact respect the other because I changed only the quantities, so it's not. But if you want to do a comparison, it's always useful to have this feature. Otherwise, you have to do it manually. I don't know it before some versions before you had to do it manually. I didn't do that, but I can only imagine. Because maybe think about this comparison not only between two different products, but for example, I have a traditional base scenario of something of what can we pick as an example? Um, of a table. Okay, also a table. But even if we use the same materials, the same type of wood, the same process to have the final product, we change the electricity mix. Okay, so for example, in order to have the steel or also the fuel of the transport for the wooden parts, it is different. So it's made more ecological, or is the electricity is coming from renewables from 100 for 100% of the total of electricity. The process will still be the same, but it will change only the process for the electricity in this case. Okay, but maybe the process of electricity in the traditional scenario was resulted as an important process in talking about impacts, and I want to change my product and have it more ecological, more green, or something like that. I want to change, and then I make the comparison. But my product still be the same, and but the results would be, of course, different. Talking about the same impact category, for example, just having some examples. So other things I want to. There's no electricity. No. Interesting. Okay. So I think I said all. I don't know if you have questions, curiosities.
No, it's a lot to process, so I have no other questions for now.
Okay. And even if your exam will be an oral test, if you want, I can send you the tutorial I followed for this lesson. If you want to, I don't know, have a better view of something, of the quantities, the process, the different features, because there are many other features, but these are not so necessary to know. Only if you have to use the software, of course, you should know them. But I don't know if you are curious to have a better look, I can send it to your email, the file, without any problems. And if you don't have questions, that's all.
Okay, yes, please. If you can send it, it will be well appreciated. Thank you very much.
Yeah. Can you write your email in the chat so I can send you right now?
Sure. Sure.
Okay. And of course, if you have other curiosities, questions, or something, you can write me on the email on my email that you will receive with the file, of course. Okay.
Okay, thank you very much.
Okay. Have a nice day. And thank you for attending.
Thanks to you. Bye. Bye-bye.
Bye. Bye. Okay, and then you write now the file. So you have completed the first module with the first professor? Yeah, on Friday. Yeah, he told me. Okay, and then you will start the second one. How is it? Complicated? This subject because it's detail into the main topic.